Question 4 on the practice exam. We are looking at variation in client profitability for an accounting firm. We're looking at the variables spent. Independent variables are hours spent working with a client, okay, and dummy variables for client type by industry. Okay, so we've got manufacturing, service, and government. Okay, so we've got a multilinear regression question here, or results. The scatter plot here looks like it shows a positive curvilinear relationship. Okay, so we've created both linear and second order polynomial models, and we've got results below. So this is basically an interpretation problem here. All right, so the first question here along the left here, or excuse me, on the right, the models are on the left, we've got the questions on the right. We've got, looking at the R-square values, the linear or polynomial model is stronger. Okay, so R-square explains the variation, the amount of variation the independent variables are attributing, or is attributed to the independent variables. So R-square in our linear model is 0.698, and in the polynomial model we've got 0.735. Okay, so in this case, because there's a higher R-square in the second order polynomial model, that's the one that's showing a stronger relationship in R-squared. Okay, now looking in part B at the adjusted R-square values. Remember, adjusted R-square is taking into account the multiple variables, and that the more variables you add, R-square is always going to be driven higher, so this is adjusted based on your sample size. So in a multilinear regression model, we would want to look at adjusted R-square as well. In this case, we've got 0.568, okay, so 56.8%. In the adjusted R-squared, and then here we've got 55.8. Okay, so in this case, then the linear model is stronger based on that output. All right. Again, higher adjusted R-squared in this model, the linear one up above, rather than the curvilinear or the polynomial model. Okay, at alpha 0.05, the overall results of both of the linear, polynomial, both or neither model is or are significant. Okay, so if alpha is 0.05 here in part C, and we're looking at the overall model, which of course is this center section of our output. In this case, we've got the probability of our linear model, which is shown right here. The likelihood of that result is 0.03. Okay, so that's significant, the overall model at the 0.03, or 0.03 is less than 0.05. And then here on the polynomial, we've got 0.05. Right, so that the overall model then is close to 5%, or actually it's closer to 6% probability, but it's not less than 0.05, so only, in part C, only the linear model, the overall results are significant. Okay. All right. So now looking at that part D, we are looking at the variables in the model, and so what we have here is at 0.05, the hours variable is or is not significant in the linear model. Okay. So hours variable right here. Look at the probability of that result. It's not less than 0.05, so therefore it is not significant, the hours variable. And then, okay, then we have the same question here in part E, but looking at the polynomial model. Okay, so again, we're looking at hours, and at the probability of that is 0.42. Okay, so we would also say that hours is not a significant independent variable in the polynomial model as well as the linear model. Okay, so both of those is not, because neither is less than 0.05. All right. Okay, in part F, we're looking at the linear model once again. At alpha 0.5, the following independent variables are significant in the linear model. Okay, so let's see if any of the variables are significant. Okay, so here we've got, they say manufacturing, service, or neither. Okay, so manufacturing and service. Okay, manufacturing is significant, right? That's 0.03 is less than 0.05, and here service 0.04. That is also significant. So we would say then that manufacturing and service are significant in the linear model. Okay, so then in part G, the question is a similar one. Right? We're going to look at the polynomial model this time, and we want to know which ones are significant, if any, of our independent variables. So looking at manufacturing, yes, that's also less than 0.05. Service, however, in the polynomial model is not significant, and so then we would just say then that manufacturing is significant. All right, and then the last question here, or the last part of the question is which model, linear or polynomial or neither, is effective at explaining the variation in the dependent variable. And so if you look at this, as you recall, if you look up and down our list here, we're sort of back and forth, right? At R square, the polynomial is more effective. At adjusted R square, the linear is more effective. This model overall is significant. This model is not. We have one independent variable that's significant, and here we have two. But overall, perhaps you might say the linear is slightly more useful, but I don't think we would say as a result that either model is particularly effective. So I would say in this case, neither model is effective.